Okay guys, so this is chapter 12, section 4. We're going to talk about alkanes and specifically their acyclic saturated hydrocarbons. Okay, so we've been talking about hydrocarbons. Those are going to be things that have carbon and hydrogen contained within them. And then the saturated part is going to be talking about just our single bonds. Okay, so here we go. Okay, so alkanes, again, a saturated hydrocarbon in which the carbon atom arrangement is acyclic. So in less specific terms, I guess, it would mean that it contains only carbon-carbon single atoms, which is it's saturated, and it doesn't contain any rings, which is our acyclic. Okay, the molecular formula fits this general rule of CnH2n plus 2. So the N just stands for how many of them are there. So if we had 4 carbons, for example, we could plug the 4 in here, and then we would plug in 4, double it, so we'd have 8 plus 2, which would be the 10. So when we look at like structural formulas, things like that, if we have one that looked like this, okay, we know that each one of those points is a carbon. So carbon, 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 carbon. So C, there would be 4 of them. So C4. And then off of each of those, this one would have 2 hydrogens. This one would have 3. This one would also have 2 hydrogens. And this one would have 3. Okay, so we can double it, and then we usually add 2 for each of those end carbons that have an extra hydrogen on them. So then if we add them up, CH4 or C4H10. Okay, if we count all of those up, we'd end up having 10. Okay, so that's the kind of general rule for that. Our simplest ones are going to be CH4, which is methane, ethane, C2H6, and then propane, C3H8. But all of those, if you pay attention to this rule up here, all of them follow that same rule. Okay? Okay, so we can represent alkanes a couple of different ways. We have the dash wedge line structures, and they look like this. And remember, the dash is saying that it's going behind the carbon, and the wedge is saying it's coming forward, kind of giving you those bond angles or a little bit of an idea of those. Our ball and stick model, so those are the ones that we have models of. We can actually use in class, so you just have the little balls. The different colors stand for different elements, and then the sticks in between represent the bonds. And then we have space filling models, which just kind of look like kind of little blobs, I guess. But again, the different colors are representing different elements. Okay, here's some of those again. So we have our regular model, the ball and stick, the space filling, and then a couple of different ones there. The last thing I want to cover is alkane shapes. So they are tetrahedral about the carbon. So around the carbon, they're going to be basically our tetrahedral shape. And all bond angles are going to be approximately 109.5 degrees, which is typical for that tetrahedral shape. Okay, and so that is all of the notes on this section, on section 4. So now I'm going to have a couple of questions for you to answer from what we learned. You can just answer them right through Edpuzzle, and then once you submit them, it'll tell you your score. Okay, if you have any questions, make sure you email me, and we will pick up where we left off when I see you next in class. Have a great day, guys.